Today I want to explain you something about the topic that I want to present it in the one conference. Let me share my screen. This is about arbitrary variable stars that I want to present it in the Ostrava meeting for astrophysics, variable stars, and now I will explain about that to you. Orbital is a star in the constellation Taurus. It is a yellow supergiant and is the prototype of a class of pulsating variables known as arbitrary variables. It is a post-asymptotic star and a spectroscopic binary about 4,700 light years away. Orbital variables exhibit changes in luminosity, which are tied to radial pulsations of their surfaces. The changes in brightness are also correlated with changes in their spectral type. While at their brightest, the stars have spectral types F or G. At their dimmest, their spectral types change to K or M. The difference between maximum and minimum brightness can be as much as 4 magnitudes. The period of brightness fluctuations from one deep minimum to the next is typically around 30 to 150 days. The pulsations cause the star to be hottest and smallest approximately halfway from the primary minimum towards the maximum. The coolest temperatures are reached near to the deep minimum when the brightness is increasing. When the brightness is increasing, hydrogen emission lines appear in the spectrum and many spectral lines become doubled due to a shock wave in the atmosphere. The emission lines fade a few days after maximum brightness. Orvita is likely a post-asymptotic giant branch star and originally sun-like star, which is in the end stage of its life just prior to the expulsion of a planetary nebula and contraction to a white dwarf. Orvita gives an insight into the limbs and deaths of stars like the Sun. Evolution models show it takes about 10 billion years for a one solar mass star to reach the asymptotic giant branch. Arbitrary variables are very luminous stars and are typically given a supergiant spectral luminosity class. However, they are relatively low mass objects, not young massive stars. They are thought to be stars that started out similar to the Sun and have now evolved to the end of the asymptotic giant branch. Late AGB stars become increasingly unstable, show large amplitude variations as Mira variables, experience thermal pulses as internal hydrogen and helium shells alternate fusing, and rapidly lose mass. Eventually, the hydrogen shell gets too close to the surface and is unable to trigger further pulses from the deeper helium shell, and the hot interior starts to be revealed by the loss of the outer layers. These post-asymptotic giant branch star objects start to become hotter, heading towards becoming a white dwarf and possibly a planetary nebula. As you see, its location here. Arbitrary variable stars, they are yellow supergiant, and then they will be here and then goes to the white dwarf. From main sequence, here arbitrary variable stars, and then here planetary nebula, and then white dwarf. Over a period of 78.5 days, it shows two maxima at around magnitude 9.5 and minimum around magnitude 10 and another minimum about 0.5 magnitudes fainter. This change in brightness is caused by pulsations. The temperature and radius vary, causing some variation in luminosity, but mostly a shift of the emitted radiation from visual to infrared. The companion is thought to be more massive than the variable primary star, but it cannot be detected in the spectrum, and it is likely to be a red dwarf. The disk surrounds both stars at a distance of about 5 astronomical units. The stars themselves have an eccentric orbit, and their separation varies between about 0.75 and 2.25 astronomical units. Orbita is well placed for Northern Hemisphere observers during the winter months, and observations can be made from August to April. However, it is faint, located in a nondescript patch of sky between the Pleiades and Beta Auriga. As you see here, here is Orbita star, and here is the Pleiades and Beta Auriga. And Orbita star is located here between the Pleiades and Beta Auriga. And the conclusion is arbitrary variable stars are very luminous stars. Their temperature vary as they pulsate, and they are thought to be stars that started out similar to the sun and have now evolved to the end of the asymptotic giant branch stars. And these are the references. Thank you. Thank you for your attention and see you next time. Bye.